Now let's go through the homework questions that you had on Wednesday. So you were asked to do question 2 on page 69. There were 3 quadratic equations and you needed to write them in completed square format. So you could do it by shortcut if you wanted, divide this by 2, square that, take it from this. Or we can do it the way that we did it in the notes and say that this is going to be x plus h all squared plus k equal to x squared minus x minus 3. And this may be the easiest way to do it. So when we square this out, we get x squared plus 2hx plus h squared plus k equal to x squared minus 8x minus 3. And then our x term gives us, the x term from this side, gives us that 2h is equal to minus 8 and h is minus 4. And our constant term is all of this, gives us that h squared plus k is equal to minus 3, but we know what h is. So when we square minus 4, we get 16 plus k is equal to minus 3. So k is minus 3, take 16, k is minus 19, and we can write down our answer in completed square format. And it was an equation, they had an equal to 0 here, so we'll include that. X plus h is negative, plus k, and k is negative, equal to 0. So that was the answer to part 1. If you're able to use the shortcut and do these faster, that's no problem at all. I'm going to keep working them out using this method though, because I feel like you can see where each part of it is coming from when you do this, and it can stop you making a mistake, which shortcuts sometimes do lead to. But what you might want to do is learn off the squaring out of these brackets. So that's always going to be x squared plus 2hx plus h squared plus k. So you can jump straight to this part if you want to, x squared minus 2x minus 5. Because you'll see, so long as there's no number in front of the x squared, this step is always going to be the same. That 2h is equal to the coefficient of x on this side, minus 2, so h is minus 1. Then I do my constant, and the constant term, it's always going to be h squared plus k. H squared plus k is equal to minus 5. So that is going to be minus 1 squared plus k equal to minus 5. 1 plus k is minus 5, and k is minus 6. So you can jump straight to doing this without multiplying out your brackets if you want to. So then writing it, we've got x plus h, but h is minus, all squared, plus k, but k is minus 6, equal to 0. And there's my answer. Right, the third one then. And the shortcut's obviously quicker. X squared minus 2x plus 1 equal to 0. And again, that's going to be that x plus h all squared plus k is equal to x squared minus 2x minus 1. Square this out, x squared plus 2hx plus h squared plus k is equal to x squared minus 2x minus 1. And then I equate my x terms. 2h is equal to minus 2, and h is minus 1 again. And my constant terms, we have h squared plus k is equal to minus 1. Did I just do the same one twice? No, it was minus 5 the last time. They were very, very similar. And that was a plus 1. So this was a plus 1 here. I just took it down wrong. We know the value of h, and so we get 1 plus k is equal to 1, which means, of course, that k is equal to 0. What does that mean? Well, when I fill it back in here, I've got x plus h, and h is minus, all squared plus k equal to 0. So this thing is, in fact, a perfect square. That's x minus 1 all squared. And of course it is. When you think about it, square the first, square the last, double the product. So you can see that that is true. But we can still just follow our method and it comes out every time if you do that. Okay, let me know if there's any part of that you're struggling with. We're going to move on with the notes, and we're going to be looking at what happens when there is something in front of the x squared. Okay, thank you.